Okay, so we talked about going from standard notation to scientific notation, but what if we want to go the other way? What if we want to go from scientific to standard? So if we want to go from scientific to standard, move the decimal places the same number of places as the exponent. Okay, that's going to tell us how many times we're moving the decimal point. Notice I'm not saying counting zeros, I'm saying moving the decimal point. If the exponent is positive, we're going to move the decimal to the right in order to make the number larger. That says larger. Add zeros as placeholders if needed, and we'll run into some of those where we have to move it over a bunch of times. There's not that many numbers there, so we just put zeros in. If the exponent is negative, move the decimal to the left in order to make the number smaller. And same thing, we're going to add zeros in. Okay, so think about this. If we have a positive exponent, remember that's going to be a big number bigger than 1. If we have a negative exponent, that's where we get those numbers less than 1. So let's look at a few examples here following these rules. Convert the number to standard notation. We have 7.83 times 10 to the 7th. Move the decimal point the same number of places as the exponent. So we're going to move this 7 places. We're going to go to the right because it's positive. So I'm going to take 7, nope, let me redo this. 7.83, and I want to move it to the right 7 times. 1, 2, 3, 4, 5, 6, 7. So I'm moving the decimal point over here, and I'm going to fill in zeros. Okay, so I'm moving it 7 decimal places. I only have 2 numbers here, so I have to fill in zeros. That gives us 7, 8, 3, and then 5 zeros. If I put my commas in, I can see that this becomes 78,300,000. Okay, so very important, guys. Don't just add 7 zeros, move it 7 decimal places. Same thing over here. Converting this 2.5 times 10 to the 4th to standard notation. I'm going to take my 2.5 and I'm going to move my decimal point over, which is right here, 4 times to the right to make it larger. 1, 2, 3, 4. So in this case, we're moving over 3 times. So I have a 2, 5, and 3 zeros, which gives me 25,000. So 2.5 times 10 to the 4th is 25,000. Now, convert the number to standard form. This time we have a -6. Sorry if that's hard to see. That's a -6. So I have 8.345. Remember, we're going to move it the same place as the exponent. So move it 6 places, but this time I'm going to the left because it's negative. And we want to make this a small number, a number less than 1. So I'm going to take my decimal point and I'm going to go over 1, 2, 3, 4, 5, 6. And I'm going to fill in 1, 2, 3, 4, 5 zeros. Okay, because that 6 tells us we go to the left 6 times. I have 1 digit here, and then I need 5 more. So I always like to write a 0 out in front because that way I don't lose the decimal point. But I'm going to have 1, 2, 3, 4, 5, 8, 3, 4, 5. Then I just write the rest of the number. Okay. Try one more example here. Convert the number to standard notation. Again, this is 3 times 10 to the -3. If I take this 3 right here, remember my decimal point falls after it. I'm going to go to the left because it's negative 3 times. 1, 2, 3. And then that's where I add in the zeros. Again, I'm putting a 0 up front so I don't lose my decimal point. 1, 2, and 3. Okay, so we get tenths, hundredths, thousandths. 3 tenths, hundredths, thousandths, 3 thousandths. All right, so now let's see how we can kind of go back and forth between them. This is standard notation. My decimal point is right here. I want it right here, so this becomes 5.82 times 10, because it's always times 10, and then I move it. It's a number. I'm going to move it to the right, or it doesn't really matter. It's a big number. Okay, so I'm going to go over 1, 2, 3, 4, 5, 6 times. and that becomes 10 to the 6th. All right, now if we have 4.25 times 10 to the 5th, this is when we put it in standard form. So I am going to take 4.25 and I'm going to move it 5 times to the right because it's a positive 5. 1, 2, 3, 4, 5. So I'm going to have to add in all those zeros. So 4, 2, 5, and this time I'm adding 3 zeros, 425,000. 1,200 or 1,200 to scientific notation. Here's my decimal point. Here's where I want it. So I know this is going to be 1.2 times 10 because it's always times 10. And I'm going to go from where I want it to where it is. I'm going to go to the right 1, 2, 3 times. And it doesn't really matter how you think of it. Understand 1,200 is a big number bigger than 1. It's going to be a positive 3. All right, this one here. Notice we have times -7. That negative tells me this, I'm going to go to the left. I need to make this a very small number. So if I take, and I'm just going to write it over here. Well, maybe, we'll see. Let me just put it here. 6.257. I'm going to the left 7 units. So there's 1, 2, 3, 4, 5, 6, 7. Which means I'm adding in 1, 2, 3, 4, 5, 6 zeros. Oops, sorry, I keep hitting crazy buttons. Okay, because it was here. So this becomes 0.123456 7, but 6257. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then 6257. See how scientific notation makes this so much easier? All right, the last one here in standard form, 0.0015. I want my decimal point to be right there because this must be a number between 1 and 10. So 1.5 times 10, I can write that right away. Scientific notation is always times 10. My decimal point is here, and I want it here. I'm going over 1, 2, 3 times to the left, which makes it a -3. All right, just to finish up with a couple more examples. This is a problem I had that had us doing more with it, but I want us to just get it in scientific notation. So let's just write each of these populations in scientific notation. Texas had a population of 26 million. 26 million. That's 26,000. That's 26 million. So scientific notation, remember my decimal point is here. I want it here. So I know I'm going to have 2.6 times 10. And I want to go over to the right 1, 2, 3, 4, 5, 6, 7 times. No decimal places. Or I'm sorry, no zeros. Don't count zeros. Count the number of decimal places. North Dakota, well, that's already in scientific notation. So I'm not even going to worry about that. That's 6.9 times 10 to the 4th. Good. Saves us a little time there. Maybe what we could do, I guess what we could do just for practice, is we could put this in standard form. I know it's not what the direction said, but I guess we could do that. 6.9. I need to move it to the right 4 places because I need to make it a big number. 1, 2, 3, 4. That's not that long. We get 69000, 69,000. All right, a couple more practices and we'll be done here. If I can scroll correctly. This is a major need here for scientific notation. Guys, when you get into upper level sciences, when you're doing with chemistry and things like that, and you have to deal with weights, you need scientific notation because I don't even want to know how many zeros there are, although we're going to have to count them. So let's write it in scientific notation. Let's pay attention here. Whatever this is, way down here at the end, I have 1.7. I want this to be 1.7. Let's count decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this is going to be 1.7 times 10 to the -27th. Remember, that has to be negative because this is a very, very, very small number. Last one. I want my decimal point right here between the 2 and the 7. So I know oxygen is going to be 2.7 times 10, always times 10. Count decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And it's not a positive 26 because that ain't a big number. It's a negative 26. All right, so going back and forth between scientific notation and standard form, it's one of those skills you're going to need for when you're dealing with huge amounts or very large numbers or very, very small numbers, which you will if you get into some of the science fields.